Welcome to question number 6 from the 2023 FRQ exam for AP Statistics. All right, in this video, we're going to go over it and fully explain the answers. I'll tell you what, it was probably one of the most in-depth, longest question number 6 I've ever seen. But there's lots of really easy parts and lots of parts that if you just do a little bit of thinking from what you've learned throughout the year, should not be overly difficult. But I understand sometimes most kids actually don't finish number 6 simply because they run out of time. But nevertheless, let's talk about it and go through it. I thought it really was a pretty cool problem. All right, a jewelry company uses a machine to apply a coating of gold on a certain style of necklace. The amount of gold applied to a necklace is approximately normally distributed. When the machine is working properly, the amount of gold applied to a necklace has a mean of 300 milligrams and a standard deviation of 5 milligrams. Now, just reading this, I'm super excited because I love it when data is normally distributed. I have the mean, I have the standard deviation, which I wrote down right here. That information alone just kind of makes problems pretty easy when they follow the normal model. All right, so here's the first question of many. A necklace is randomly selected from the necklaces produced by the machine. Assuming the machine is working properly, calculate the probability that the amount of gold applied to the necklace is between 296 milligrams and 304 milligrams. Now, we're only talking about meaning a single necklace. So as long as we're talking about a single necklace from this population, once again, the mean is 300, the standard deviation is 5. So the question was, again, I'm just trying to notate this, the probability that the amount of gold is somewhere between 296, and I have a typo there, sorry, 304 is what it should say there, 304 milligrams. Okay, now to actually find that probability, I need to go ahead and get the corresponding z-scores. So here is my work right here to find the z-score for 296, subtract the mean, divide by 5, I got negative 0.8 exactly. And then I found the z-score for 304 minus 300, divide by 5 to be positive 0.8 exactly. Now that actually makes complete sense because 296 is 4 below 300, 304 is 4 above 300, so it makes sense that they're the exact same z-scores, just one negative, one positive. So finding the probability that the amount of gold is between 296 and 304 would be the same as finding the probability in the normal model from negative 0.8 to positive 0.8. Now, you could use your normal model tables to calculate that probability, or you could just go ahead and grab a calculator. Again, do not write on the test normal CDF or that. They don't want to see that at all. They want to show the use of the z-scores and the proper notation for the answers. So I'm going to get the answer. You could also get the answer from the z-tables, literally going from a low value of negative 0.8 to a high value of positive 0.8. Now, listen, you could actually type in 296 and 304 and change the mean to 300, standard deviation to 5. But again, you got to show some work. So I actually like to incorporate the z-scores because that's what you're showing on your test. By the way, there's my answer, 0.576 right there. But again, you got to show work. If all you put is 0.576, they consider that a naked answer, meaning that it doesn't come with any work or any idea of what it even represents. And that's why they really like the notation of showing that I'm looking at the z-scores and I'm also looking at the amount of gold that would be equivalent to that. So pretty easy question. If you had a teacher that definitely talked to you about how to use the normal model and calculate probabilities, boy, that should have been a simple one. All right, now comes a little bit more reading we got to do. The jewelry company wants to make sure the machine is working properly. Now, again, this is the machine that sprays the gold onto the necklaces. They need to make sure it's working properly. Now, don't forget what properly means. Mean amount of gold, 300, standard deviation 5. Each day, Cleo, a statistician at the jewelry company, will take a random sample of the necklaces produced that day. Each selected necklace will be melted down and the amount of gold applied to that necklace will be determined. But because a necklace must be destroyed in order to determine the amount of gold that was applied, they do not want to use very large samples, so Cleo will use a random sample of 2 necklaces. So again, to actually check how much gold is on these necklaces, they got to melt them down, destroy them. So that is why they want to be able to make this determination with a very small sample size of 2. All right. So Cleo starts by considering the mean amount of gold being applied to necklaces. After Cleo takes a random sample of 2 necklaces, she computes the sample mean amount of gold to those 2 necklaces. So now she's no longer working with a single necklace. She's working with 2 necklaces, which means she's working on the mean amount of gold in those 2 necklaces. It clearly says that several different places. All right, suppose the machine is working properly and it has that mean of 300 and that standard deviation of 5. calculate the probability that the sample mean amount of gold applied to a random sample of 2 necklaces will be greater than 303 milligrams. Now, because I'm now working with a sample size of 2, that means we need to consider a sampling distribution. A sampling distribution is a distribution not of the population, but a sampling distribution here would be that for the mean amount of gold in 2 samples. So the first thing we got to do is talk about the center of that sampling distribution. What is the mean of all possible sample means of size 2? Well, it should be 300. If the 300 is the mean, I don't care if you look at 2 necklaces or 100 necklaces, the mean should be 300. But the standard deviation is where we're going to see that change. The standard deviation for the population is 5, but now that we're dealing with a sample size 2, we're going to take that 5 and divide by the square root of 2 to get the standard deviation for our sampling distribution. That is the 3.536. That is an important piece of this problem that if you don't do, you will get it wrong. All right, now what about the shape? Well, of course, the shape of that sampling distribution will be normal because the population of the amount of gold is already normal, so even a sample size of 2 will still follow that normal distribution. So now they want me to figure out the probability that the mean amount, X bar, is greater than 303 milligrams. All I have to do is get the z-score for 303 milligrams. There's my work right here for that. 303 minus 300 divided by that standard deviation of the sampling distribution. I got 0.8484. And then again, this is where they do require that you show this, that a probability that a mean is greater than 303 is equivalent to a z-score being greater than 0.8484 in the normal model. Now to get that, I'm going to once again go back to my normal CDF. I'm going to start at that z-score of 0.8484 and go all the way up to infinity. And after looking up to that infinity, I'm going to paste that in, and I get a probability of 0.1981, and that is, of course, how I arrived at my probability. 19.81%, 0.1981, so 19.81% of all possible samples of size 2 will produce a mean greater than 303 milligrams. All right, pretty easy for part B, section 1. Now on to section 2. So part 2 says, suppose Cleo took a random sample of 2 necklaces and resulted in a sample mean amount of gold applied of 303 milligrams. Would that result indicate that the population mean amount of gold being applied by the machine is different from 300 milligrams? Justify your answer without performing an inference procedure. So again, let's just quickly go back to this question real quick. What we just got done finding is the probability that a sample of 2 necklaces has a mean greater than 303 milligrams. We got 0.1981. So now what they're saying is that happened. She actually got a sample of 2 necklaces and the mean was 303. Would that indicate that something is wrong and the machine is not working? No. Here's my justification. If a sample mean of 2 necklaces was 303, it would not indicate that the population mean amount of gold being applied by the machine is different than 300. The reason is due to the probability. I found that the probability of the mean amount of gold from a sample of 2 necklaces being greater than 303 milligrams to be 0.1981 on the assumption that the population mean is 300 milligrams. Basically, that's a p-value that I just found. It's the probability of a sample mean occurring or more extreme on the assumption that the null is true, which is the 300 milligrams true. Now, they don't want you to do an inference procedure here, but they do want you to understand that you just calculated a p-value, even though you didn't realize it. So a probability of 0.1981 is far too likely, again, given the fact that the mean is 300. So again, just trying to simplify this, meaning that a sample mean of 303 milligrams is not unusual to occur if the population mean is 300. Again, I just found out that the probability of a sample mean being 303 or greater is dang near 20%. So that means a sample mean of 303 is about 20% likely to occur, meaning it's not weird. So if a likely event were to occur, it would not indicate that the population mean needs re-examined. So the mean is supposed to be 300. Yes, our sample came back at 303, but it's not that high. Again, even look at the z-score. The z-score for 303 in this sampling distribution for the mean of 2 necklaces is 0.8484. So it's only a little bit above the mean. It's not even 1 standard deviation above. That is not weird at all. That would not give us reason to think that the machine is working incorrectly. Okay, so that completes part B. A couple different parts there, a lot of explaining to do. Now we're going to move on to the next part. which is a little complicated, so you got to really take the time to read this. Okay, now Cleo will consider the variation in the amount of gold that the machine applies to necklaces. Everything we've just done so far dealt with the mean of the amount of gold. Now she wants to dive into the variation of the amount of gold. Because of the sample size being 2, Cleo will use the sample range of the data for the 2 randomly selected necklaces rather than the sample standard deviation. I mean, when you only have 2 necklaces, the standard deviation might not be worth measuring. But looking at the range, the distance between the 2 values, is actually really easy. There's only 2 values, just one's going to be the min, one's going to be the max, so just subtracting to find the range. Now, Cleo will investigate the behavior of the range for samples of size 2. Again, that's what a sampling distribution is doing, right? It examines the behavior of all possible sample statistics. In class, we deal with means and we deal with proportions. We don't usually work with ranges, but that's what they're trying to get you to understand. So she will simulate the sampling distribution of the range of the amount of gold applied to 2 randomly sampled necklaces. She will generate 100,000 random samples of size 2 independent values from a normal distribution with a mean of 300 and a standard deviation of 5. The range is calculated for the 2 observations in each sample. So again, 100,000 random samples she's simulating, which will give her 100,000 different ranges. The simulated sampling distribution of the range is shown in graph 1, which I'm about to show to you. Now, they then repeated this process for a standard deviation of 8, and then again for a standard deviation of 12. So again, we're assuming that the standard deviation is 5. That's how it's been the whole problem. But then they want us to take a look at repeating this idea of looking at range when the standard deviations of the populations are larger. So here are those graphs. So in this top graph, we're looking at all possible ranges. So we looked at 100,000 different samples of size 2. From every one of those samples, we calculated the range, and here are the results. Okay, makes sense. Here's the results when the when the standard deviation is 8, and here's the results when the standard deviation is 12. Now, before we even read the next question, I noticed that all of them are skewed to the right, but I noticed that for 5 to 8 to 12, that becomes more skewed to the right. None of them are what I would definitely classify as normal, and they all, again, are skewed right. All right, so now let's actually continue on to what the next question says. All right, use the information in the 2 graphs or in the 3 graphs to complete the following. First, describe the sampling distribution of the sample ranges for a random samples of size 2 from a normal distribution with a standard deviation of 5, as shown in graph 1. So basically, they're just saying, hey, describe what you see in graph 1. So, graph 1, I said, has a shape that is skewed to the right. Of the many ranges, the typical range between the 2 sample means would be around 5. Again, remember when you describe a distribution, you want to talk about the shape, skewed right, and then you want to talk about the center. I said the center would be about right here. When your data is skewed, you definitely want to think about the median, so I'm thinking about that 50% mark. And again, I'm saying somewhere right around 5 would be a good measurement of the median. I mean, maybe the other day it's closer to 6 or 7, but I think 5 is at least a good starting point. Now, I also want to talk about spread. So the spread of them goes from as low as 0 to as high as possibly 25. So again, bottom out value down here would be a 0. That would actually mean that the 2 necklaces have the same amount of gold, which is why the range would be 0. And it does look like there might be possibly some very low sample ranges of possibly as high as 25, which would mean that one was way bigger than the other in terms of the amount of gold. So again, yes, understanding everything that's going on in this problem is a little bit consuming, I understand. But at the end of the day, all they're asking you to do here is talk about what you see in that graph. And shape, center, spread. I see shape skewed right. I see a center around 5 milligrams in terms of the range. And then the overall range of the ranges was from 0 to 25. But again, the large majority are probably actually 0 to 10. So hopefully that makes sense. All right, now the second question here says, describe how the sampling distribution of the sample ranges for the sample size of 2 changes as the value of the population standard deviation increases. So now they want us to describe how these different shapes or how these different distributions change when we go from when we go from using a standard deviation of 5 to a standard deviation of 8, standard deviation of 12. So what I was noticing is that they're all skewed right, but the bigger the standard deviation, the more skewed they become. The other thing that clearly changes is the center. For graph 1, the center's around 5. For graph 2, the center's around 10. For graph 3, the center's probably more around 15. So the center is increasing. So that's what I kind of wrote down here. I said as the population standard deviation increases from 5 to 8 to 12, the sampling distributions become more and more skewed right. The typical range in the center increases as well from 5 to roughly 10 to 15 milligrams in the 3 graphs. When the standard deviation of the population increases, the spread between the two sample appears to increase as well. Actually, that should make complete sense, because when the amount of gold varies more, then the chance of the range between the two necklaces being larger will increase. So again, think about that, what I'm saying there. We're increasing the standard deviation. That means you're increasing the spread of the population. And if the spread of the population is bigger, that means you're going to have more variation within it, which means you could easily get a low amount of gold in a necklace to a high amount of gold in the necklace, which would mean that the range, the value in between them, could be bigger. Now, when your spread originally is very small, with standard deviation of 5, you're not going to get very big ranges. Now, you might get a couple big ranges, but the majority are going to be small ranges. When you increase it to as high as 12, that means that your population is more spread out, which means your individual necklaces are more spread out, which means that the range between any two necklaces could potentially be more spread out, which is why we see the center being more spread out, around 15, versus from the original graph around 5. So again, hopefully if you're really understanding range and how when the data that those values come from is more spread out, that could easily interpret to the range between them possibly being more spread out, which is exactly what these graphs show. Okay, moving on to the final section. Again, a lot of in-depth problems. It's a very long number 6 here. All right. Recall that Clio needs to consider both the mean and the standard deviation of the amount of gold applied to the necklaces to determine whether the machine is working properly. It's not just focusing on the mean being 300, but it's also focusing on the standard deviation needing to be 5. All right. Suppose that 1 month later, Clio is again checking the machine to make sure it's working properly. Clio takes a random sample of 2 necklaces and calculates the sample mean amount of gold applied to be 303 milligrams and the sample range to be 10 milligrams. Recall, the machine is working properly if the amount of gold applied to the necklaces has a mean of 300 and a standard deviation of 5. Okay, here's the question. Consider Clio's range of 10 milligrams. That was the range in her sample that she just took 1 month later. If the machine is working properly with a standard deviation of 5 milligrams, is the sample range of 10 milligrams unusual? So to answer this question, I went back to that sampling distribution where we had looking at the ranges from the population with a standard deviation of 5. And I said, okay, this is literally a sampling distribution of exactly 100,000 different ranges. And I said, well, where's 10? Well, there's 10 right there, right? That was what her range of her 2 necklaces ended up being. So I said to myself, is a value of 10 for the range unusual? And I said, no, it's actually not. Now, it's on the higher side, but there is plenty of ranges that were more than 10. It's not like 10 was way to the right-hand side where I would say, wow, that should not be happening. In fact, a range of 10 appears to be very, well, typical. So I said, no, I would not say that a sample range of 10 milligrams is unusual. Based on the sampling distribution provided, one can see that a range of 10 milligrams is on the higher side, but there are plenty of sample ranges that are even higher. So I would not say it is significantly high. That would tell me that the standard deviation of 5 is wrong. Remember, this sampling distribution was built on the fact that the standard deviation is 5. Now, just to play counterpoint here so you understand, if her range was 40, let's just say that the range of her 2 necklaces, from the smallest to the largest, the distance was 40 milligrams. I would say, whoa, that is crazy unusual. Something must be broken to create a range that big. Looking at the sampling distribution, nothing even came close to a range of 40, so that would definitely indicate that the standard deviation is wrong and the machine is possibly broken. But A range of 10 is simply not unusual at all. Looking at that sampling distribution, it doesn't appear to be high. I would venture to say maybe 20 to 15% of ranges are more than 10, which again is not unusual. All right, final question of this very long problem. Do Clio's sample mean of 303 milligrams and range of 10 milligrams indicate that the machine is not working properly? No. And it's kind of funny that they asked this question because I've literally already answered both of these questions. So I'm literally just going to repeat myself here. The mean of 303 milligrams and the range of 10 do not indicate the machine is broken or has a problem. We already discussed back in, part B, feels like infinity ago, but we already discussed that a sample mean of 303 milligrams or more has a probability of 0.1981 if the machine has a mean of 300 milligrams. Meaning that it's not nearly unlikely enough for me to indicate that something is wrong. We've already shown that a mean of 303 for 2 necklaces is only a little bit above the truth of 300. I think the z-score was like 0.8484. It's not unusual enough for me to say something's wrong. Furthermore, I literally just got done explaining that a sample range of 10 milligrams is also not that unusual of a sample range if the standard deviation is 5. Again, go back to that sampling distribution. A sample range of 10 for 2 necklaces is not so unusual that I would question if 5 is the real standard deviation. So altogether, I can't say for certain that the machine has a mean of 300 and a standard deviation of 5, but my sample, or not my, Clio's sample, does not indicate otherwise. And that's really the important fact of all of this together, right? At the end of the day, I'm never going to know for a fact, 100%, that the machine is perfectly operating at a mean of 300 and a standard deviation of 5, but her sample of 2 necklaces does not indicate that the mean is unusually high. It does not indicate that the range is unusually high. So at the end of the day, I don't think that the machine is broken or she should think otherwise. All right, that's it for a really long problem. Hopefully you understood it. It's a pretty good one. It's really involved. But again, going back to the first couple questions, I hopefully, just dealing with a normal model, hopefully it wasn't too difficult. All right, hit me up with some questions in the comments if you have any, and good luck, and hopefully watching this video helped explain the problem.